Well, since I did multiplication before, I might as well just do squares of numbers. Let's do 521 to the power of 2, 500 to the power of 2. Then you just count by multiplying by 2 and adding 1. So you say you had 1001, then you add 1003, then you add 1005, and then all the way up to, well, 521. So 1041. Yeah, you do +1 for here and -1 for the end. I think. Why? Not asking. So first you add all the thousands together, 21,000. Then what remains is the average of 41 plus 1, which is 21. That times 21, so 21 times 21, which is just 440, but then plus 41 because it's, you know, the double of this minus 1. Right? No, 400 because it's 20 times 20 and that's 441. Blah blah blah. I tried making this video before, but it didn't really work. Anyways, they just do 250,000, 21441, and that equals. And what is 521 to the power of 2? And ta-da! Here you go, 271441. Boom. Big brain. Okay, let's do a different one. I've already done that one before, but let's just do a different one, same method. 1065 and 1000. So what would you need to add? Well, 2001, 2003, and then all the way up to 2164. No. What is that? That's 2130, so that's 2129. Then you average out. No, wait, first you just do 2000 times 65. Okay, 2000 times 65 equals 130 times. Removes all the fluff. Then you just take the average, which is all the way handy dandy 65 times 65. So you will get squares by trying to calculate squares, but just deleting other squares. Okay. 65 times 65. Well, let's just do something simpler. 3600, and then just add a few stuff. Okay. Next would be 61. So that's 21, 123, 125, 127, and 129. All culminating in 125 times 5, or pretty well known to be 625. And ta-da! So 3600 plus 625 is 4225. And then you just add those two together. So bam. Guess what the hell that number might be? Okay. Oh, sorry. I want to fix that. And we're putting a million here. Guess what we do with that million once we copy it over to 1065? Oh yeah, we just add these numbers in it. And let's see. Then we just, formulate the actual sum. And then we say, boom. Now, is that correct? Let's do that. 1065. Wow, bada bing, bada boom. Okay, well that's quite easy. Well, can we get an intuition for it? Well, let's see. Let's just do, I don't know, 1 to 18. This should be quite easy because we just take 12000 and that equals 144,000, and then we just say 2401 all the way up to 24. Oh, 35, 36, 18, 18 times 18, and then 24,000 times 18. And you can see the recurring pattern soon. So, well, 18 times 18 is just 225 plus. I think 16 to the power of 2 is 252, but sure, we just do 15 and 16, which is 31 for 256, yeah, 33, 35, going up to 99. So we just do that, 99 equals 3 to 4. Okay. And then we just do this annoying little sum, 24 times 18. Well, 24 times 18 is just 21 times 20, which is already like 4 for 1, which was in the previous sum. They need to delete some numbers. That's 3 times 3. So 9, right? So we just say this is 9 less. 4, 3, 2. Well, it looks to be correct. Okay, and then we just say and then we add this one, and then we copy this number over, and then we just put this number in there, and then we say 12018 power of 2, and it's completely correct again. This is something not even I can fuck up, apparently. Well, I can if you start doing fucking things like this, of course. Like, do you think I'm reasonably able to find something that I could actually fucking square with this nonsense? But still, not too bad. One more example, I guess, before I end the video. Sure, let's make something spicy enough. So, is this something? Sure. Okay, we just do 1, 2, 0, 0, 0, 0, equals 1, 4, 4. Now we say, well, what was it again? 1, 2, 0, 0, 0, 0 times 1650 and 1650 times 1650. Of course, I can just double check by inputting a few example numbers. Oh no, wait, it's 240,000. Because you know, it's like 2, 4, 0, 0, 1, 2, 4, 0, 3, and that all the way up to 2, 4, 3299. And so it averages out to 21165. Okay. So you got this stupid fucking number. And then you got this stupid fucking number. Well, which stupid fucking number would I like to begin with? Let's begin with the smaller one. Of course, I will just use my multiplication method trick, because no way am I gonna count this. Or maybe I can. After all. Wait. I keep forgetting the square root of 16. I think it's 256, right? Yeah. So 1600 to the power of 2 is just 256. Oh. Okay. And then what was it again? Okay, the one with this with the difference, and then one of this with the, yeah. So, I'm completely forgetting what I'm doing. Well, one would be, oh, I see, I split these in two. That's what I didn't get for a little one. You can add them together, and that's the actual sum. So, this would be 50 times 50, and which equals 2500, and 3200 times 50, which equals 1600. You add these together. Sure, let me just copy this number down, and let me just copy this number down. And let me just add that to this, which just means that we will have to change this into a 7, this into a 2, and this into a 225. No, that this is not a change of the actual one, this is just all notation. And then you basically have this part solved, so let's just put in this. And now this fucking number. Okay, let's just do 20 times 1650. Okay, that's just 3, 3. Oh, oh, oh. Okay. And then we just Add 20% of that, so that's 6,600. Okay. Just to see how many cereals I need to add, which is 4. And then we just add those bad boys up together. So let's just the 3 actually fits inside the number. So that's just a 7. And the rest you can just copy and paste over. Okay, well that is the sum I think, so let's just 1, 2, 1, 6, 5, 0, 2 to the power of 2 is 1, 4, 7, 9, 8, 7, 2, 2, 5, 0, 0. Oh, and that is because I forgot to add this number. So let's just add this number. If I change this into an 8, then just add this. And now it should be correct, right? Yeah, okay. Don't forget to add your numbers, boy. Well, that's just a method to, like, do most squares. It's not too hard, I guess. You just pick an easier square, you double it and multiply it by the difference of the original square, and then you just multiply the square itself by that different square. And yeah, that's the method. Well, that's it.